This black hole is so massive, it shouldn't exist. Meet TON 618, the cosmic monster that breaks every rule. TON 618 is one of the largest black holes ever discovered. Its mass? 66 billion suns. That's not a typo. This thing is so big, it challenges our entire understanding of how black holes grow. TON 618 is an ultramassive black hole located 10.4 billion light-years away. It sits at the center of a quasar, a hyperbright, energy-spewing galactic core. Its accretion disk shines 140 trillion times brighter than the Sun. It's so bright, we can see it across the universe. Here's the paradox: black holes grow by consuming matter. But even the fastest growth models can't explain how TON 618 reached 66 billion solar masses so early in cosmic history. To reach this size, it would need perfect feeding conditions, zero interruptions, and billions of years of non-stop growth. But TON 618 existed when the universe was still young. It's simply too big, too early. Scientists have three ideas. 1. Direct collapse black hole. A massive gas cloud collapsed directly into a giant black hole, skipping the star phase. 2. Runaway mergers. Dozens of black holes merged repeatedly in a dense early universe. 3. Unknown physics. Some researchers think TON 618 hints at new growth mechanisms we haven't discovered yet. To understand its size, if TON 618 replaced the Sun, its event horizon would swallow the entire solar system all the way past Pluto. This is not a black hole. This is a cosmic empire. TON 618 is a reminder that the universe still hides monsters we can barely comprehend.
Where impossible ideas become possible. Meet HD 140283, the Methuselah star. In 2013, astronomers used the Hubble Space Telescope to measure the age of a nearby star. What they found broke cosmology. How can a star be older than the universe? The star, HD 140283, appeared to be 14.5 billion years old. But the universe itself is only 13.8 billion years old. This star is older than everything, older than galaxies, older than time itself. HD 140283 is a metal-poor subgiant located in the constellation Libra. It's about 190 light-years from Earth, and it's moving fast, over 1.3 million kilometers per hour. Its low metallicity suggests it formed very early, when the universe had barely begun creating heavy elements. Astronomers call it the Methuselah star, a cosmic relic from the dawn of time. Using precise parallax measurements, scientists calculated its age to be 14.5 billion years, with an uncertainty of plus or minus 800 million years. Even at the lower bound, it's still older than the universe. This creates a paradox. Either the star is older than everything, or our understanding of the universe is flawed. There are three main theories. 1. Measurement error. The age estimate might be off due to uncertainties in distance, luminosity, or stellar models. 2. Early formation. The star may have formed just hundreds of millions of years after the Big Bang, earlier than expected. 3. New physics. Some scientists suggest this could point to flaws in our cosmological models, or even hint at pre-Big Bang structures. HD 140283 is a reminder that the universe still holds secrets. If a single star can challenge the age of everything, what else might we be missing?
Where impossible ideas become possible explanations. There is a galaxy in the universe that should not exist. A structure so old, so massive, and so perfectly formed that it breaks the timeline of our cosmos. Found by James Webb Telescope in July 2022, scientists call it the impossible galaxy. But here at MindOrbit, we believe something far stranger is happening. This galaxy appears billions of years older than the universe itself, older than the Big Bang, older than the moment time supposedly began. According to standard physics, that is impossible. But what if the standard model is wrong? MindOrbit believes this galaxy may not belong to our universe at all. It may have drifted in from somewhere else, a neighboring cosmos, a parallel reality, a place where time began long before ours. If that is true, then the Big Bang was not the beginning. It was just a start of one universe in a much larger and much older multiverse. And this galaxy might be the first piece of evidence that our universe is not alone.
You are watching MindOrbit, where impossible ideas become possible explanations.
There is a place in the universe where almost nothing exists, a cosmic void so large, it should be impossible. In 1981, astronomers discovered something strange in the night sky, a region of space so empty, so vast, and so unnatural, that it immediately challenged our understanding of the universe. They called it the Botas Void, a cosmic hole nearly 330 million light-years wide. If the Milky Way were a grain of sand, the Botas Void would be the size of a football stadium. And inside this enormous region, there is almost nothing. According to standard cosmology, matter in the early universe clumped together over billions of years. Galaxies formed, clusters formed, and cosmic filaments stretched across space. But the Botas Void breaks this pattern. A region this large should contain thousands of galaxies. Instead, astronomers have found only about 60. That is less than 1% of what should be there. A structure this empty should not exist in a universe shaped by gravity and cosmic evolution. The Botas Void is so big that light would take 330 million years just to cross it. That means this structure had to form extremely early, but the early universe was too uniform and dense. For the Botas Void to exist, something must have pushed matter away or prevented it from forming. There are three leading theories. First, cosmic inflation irregularities. Second, multiple smaller voids merging, like bubbles combining into one giant bubble. Third, unknown physics. Some believe the Botas Void hints at forces we do not yet understand. The Botas Void is one of the largest known structures in the universe, and its existence suggests that our cosmic map is far from complete. Ideas become possible. A single star in the universe breaks everything we know about physics. In March 2023, astronomers confirmed the existence of a star that should not exist. Its name is Earendel, the most distant individual star ever observed. Its light has traveled 12.9 billion years to reach us. We are seeing it as it was only 900 million years after the Big Bang. But that is not what makes Earendel impossible. When Hubble first detected Earendel in March 2022, astronomers thought it was a mistake. The star appeared too bright, too massive, and too far away for such an early universe. Then the James Webb Space Telescope confirmed it in 2023. Earendel is real, and it is over 1 million times brighter than the Sun. It may be 50 to 100 times more massive, and it lives in a galaxy that should not have existed so early. According to standard cosmology, a star like this should not exist so soon after the Big Bang. The early universe was chaotic, hot, dense, and made almost entirely of hydrogen and helium. To form a massive star like Earendel, you need heavier elements, stable galaxies, and several generations of earlier stars. But 900 million years after the Big Bang, there should not have been enough time for any of that. Earendel challenges our entire timeline of cosmic evolution. There are three leading theories. First, gravitational lensing. A massive galaxy cluster acts like a cosmic magnifying glass, boosting Earendel's brightness by a factor of 1,000. Second, Earendel might be a population 3 star, one of the first stars ever formed. If true, this would be the first direct evidence of such a star. Third, our cosmology might be incomplete. JWST discoveries from 2022 to 2024 already suggest that the early universe formed stars and galaxies much faster than our models predict. Earendel may be another clue. If Earendel is a population 3 star, we are looking at the first generation of light in the cosmos. If not, then our understanding of how quickly the universe can build complex structures is wrong. Either way, this star should not exist, but it does. MindOrbit. where impossible ideas become possible explanations.
This galaxy appears in 5 different places in the sky at the exact same moment. Not because it moves, not because it repeats, but because space-time is bent into a cosmic mirror. This is MRGM 0138, first spotted in deep Hubble images, and later examined in detail by the James Webb Space Telescope in 2022. MRGM 0138 lies 10 billion light-years away, but we don't see it once. We see it 5 times. A massive cluster, Max J0416, bends space-time so strongly that light splits into multiple paths. 1 galaxy, 5 images, a natural cosmic duplication. In 2014, Hubble captured 2 supernovas inside this lensed galaxy. One of them, SN Requiem, appeared in 3 of the lensed images, and astronomers calculated that the final appearance will reach Earth in the year 2035. A cosmic replay, a time-delayed explosion. But MRGM 0138 isn't just a visual glitch. It's a scientific tool, one of the most valuable gravitational lenses ever found. By comparing the arrival times of each image, astronomers can measure the expansion rate of the universe with incredible precision. It even helps test dark matter models, because the exact shape of each lensed image reveals how invisible mass is distributed inside the cluster. But the real mystery isn't the lensing, it's the galaxy itself. When James Webb observed MRGM 0138 in 2022, it revealed a structure far too mature for its age. It shouldn't look like this. Not this early. Not with this symmetry. It shouldn't look like this. Not this early. Not with this symmetry. MRGM 0138 is a cosmic laboratory, a natural telescope, a time machine, and a challenge to our understanding of how fast galaxies can grow. 1 galaxy, 5 images, a supernova that returns, and a perfection that shouldn't exist.
This is not just a star, it's a neutron star, the collapsed core of a supernova, a sphere the size of a city, with the mass of 2 suns. Its gravity is so extreme, it doesn't just bend light, it bends time. Imagine standing near one. Your clock ticks slower, your heartbeat stretches. 1 second for you might be 2 seconds for someone far away. Neutron stars are cosmic paradoxes. They're dead, but they pulse. They're tiny, but heavier than stars. They're cold, but they fire beams of radiation like cosmic lighthouses. Some spin 700 times per second. That's faster than a kitchen blender. We call them pulsars. And they're so precise, we use them to measure time better than atomic clocks. Some neutron stars bend light into rings. Others may hide black holes inside. And some might be made of pure quark matter, a form of matter so dense we've never seen it on Earth. These stars are laboratories of physics. They test the limits of gravity, matter, and time itself. And they're not rare. There could be hundreds of millions in our galaxy alone. Each one, a frozen echo of a stellar death. Each one, a reminder that the universe is stranger than we ever imagined. This is the star that warps time. This is MindOrbit.
Something massive is pulling our entire galaxy, dragging the Milky Way through space at over 600 kilometers per second. And the strangest part, we can't see what's pulling us. Astronomers call it the Great Attractor, a gravitational anomaly so powerful that hundreds of galaxies are falling toward the same point in space. Not drifting, not floating, falling. This thing influences a region hundreds of millions of light years across. It shapes the motion of entire superclusters. Yet, it's hidden behind a thick wall of dust and stars in our own galaxy, a place astronomers call the zone of avoidance. We know it's real because galaxies don't move randomly. They flow, they stream, they accelerate toward the same invisible destination. Like leaves drifting toward a drain we can't see. Some scientists think the Great Attractor is a massive cluster of galaxies hidden behind dust. Others believe it's part of something larger, a structure called Laniakea, the supercluster we belong to, a cosmic continent made of thousands of galaxies.
But there's a more unsettling idea. What if the Great Attractor isn't an object at all, but a direction? A pull from something beyond the observable universe, something outside our cosmic horizon. Right now, the Milky Way is being dragged toward it at incredible speed. Every star, every planet, every one of us is moving through space because of something we still don't understand. We don't know what waits there. A massive cluster, a deeper void, or something we don't have a name for yet. The Great Attractor is pulling us all, and we're still trying to understand why. This is MindOrbit.
We've explored impossible stars, impossible galaxies, impossible forces. But the greatest impossibility is the universe itself. How can a universe filled with contradictions exist at all? The laws of physics are so precisely balanced that even the smallest change would erase everything. Gravity, light, time, matter, all tuned with impossible perfection. Why is there something instead of nothing? Why does the universe exist when non-existence is far more likely? 95% of the universe is invisible. Dark matter holds galaxies together, and dark energy tears them apart. We don't know what either of them are. The universe began from a point smaller than an atom, where physics breaks, where time didn't exist, where everything came from nothing, and its future is just as impossible. Heat death, big rip, vacuum decay. 3 endings, none of them gentle. A universe that shouldn't exist, filled with objects that shouldn't exist, observed by beings who shouldn't exist. The greatest impossibility is that we are here to witness it. This is the impossible universe. This is MindOrbit.